Hi everyone, here we are back at question 2 of this week's practice where we're graphing more trigonometric functions. Like the last video, I'm going to take a little bit of time to go over what cosine looks like and how we create these points. Again, just like the last video as well, we're going to use 5 key points, the max, the principal axis, the min, and then when it hits the principal axis 2 more times as well to really plot this. So without further ado, let's get into it. Before we get into the actual graphing of this, let's take some time just to look at the unit circle. So as we did in the last problem, we were looking at the sign, so we were looking at the y values of each ordered pair or point on this unit circle as we make our way around one full period, we say. So where pi 6, if we take, say, the sine of pi 6, we're looking at the y value, which is the vertical height above the x-axis that this point right here falls on, or falls up, or flies up. So this one would be 1/2. So if we take something like the cosine of pi 6, or if we want to 30 degrees if we're working in degrees, but now we're in radians, cosine of pi 6 is root 3 over 2. And that root 3 over 2 is the horizontal distance from the y-axis this point lies. So from this point all the way over to the y-axis is root 3 over 2, which is something like 0.72, something along those lines. So in this case, if we start at 0 and just think about this and look at what's happening, well, right away we notice something's different in that the cosine of 0 radians is 1. So where 1 was the maximum that a sine function had, cosine follows the same thing because this is the same sort of circle. It's the exact same unit circle it falls on. It never is more than 1 unit away from the origin here. So we would say the cosine of 0 is 1. So we're going to look at this in Desmos real quick, but let's walk through it first. So if we take the cosine of 0 radians, that's 1. So this is actually going to start at a maximum value. Now as we rotate around or follow one period, we take the cosine of pi halves. We're looking at the x value of this ordered pair. That's 0, so that's our principal axis. Continuing on, cosine of pi is -1. So halfway through, it's at a minimum, actually, halfway through its period. Then 3/4 of the way around a period, or around the circle, it's at an x value of 0. So cosine of root 3 over 2 is 0, so back at the principal axis. And finally, cosine of 2 pi is the same thing as cosine of 0. That is 1 again. So a cosine function goes maximum when it starts, principal axis, minimum halfway, 3/4 of the way through, it's back at the principal axis, and then one full period or revolution around the circle, it's back at a maximum. So before we look at these in Desmos, if you haven't yet, I'd encourage you just to type y equals sine x, y equals cosine x below, and look at the relationship between these two functions. They are very closely related, and you're going to see that right away if you put them into Desmos. So take a moment to do that if you haven't. But now, let's just look at y as cosine x. So just like we expected, the beginning point is a maximum. Then 1/4 of the way through a revolution or period, it's on the principal axis. Minimum halfway, principal axis 3/4, and back to a maximum. So we say it oscillates, just like the sine function, between 1 and -1. As far as I scroll over, no matter how many revolutions or periods I go through, it's never going to be above +1 or below -1. So we're going to use this information, this pattern, to plot this cosine function. So I'm making a big change here. I'm trying a tablet on this end to try and work through these, so bear with me on some sloppy handwriting. I'll get better as we go. So we're going to use that guide for cosine, as I said, to plot this. So what we have here now is a transform cosine function, but again, we know what these transformations do because we looked at them at the beginning of the year, or you may need a quick refresher, but we can have a good idea of what the cosine function is going to look like actually. One difference here, this is from 0 to 2 pi, where the problem one was from 0 to 4 pi. So this is just a single oscillation, so we may need to extend a little bit in each direction, but we'll go with it. So, just like in the last problem, we're just going to start by putting down an axis, and we'll set up our coordinate system. Alright, let's try this out now. So we'll just go with black here. So there's my y-axis. Here's my x-axis. So here's x. Let's call this right here 2 pi. Alright, and then we're going to go from 0 radians to 2 pi on our x-axis. I'm going to make this a little smaller. So starting with the cosine function, we know this plus 1 has a vertical translation, or it's a vertical translation 1 unit up. So that's going to shift our principal axis 1 unit up. So right here, 1. Let's plot our principal axis in red. So that's our principal axis. It's going to oscillate through this as it goes through rotations, but we know where it is at all times now. So our amplitude is the number in front, is what we're multiplying the trig function by. Well, that's actually a -1. So that tells us that this is not stretched vertically in any way. So we're going to be 1 unit above our principal axis and 1 unit below. So if our principal axis is 1 unit above, it's going to oscillate between 2, and it's going to oscillate between 0. So let's go ahead and put dotted lines there as well. So here's the maximum. It's never going to go above this line. And my minimum is the x-axis. It's never going to go below the x-axis. So it's going to oscillate through these points as we go through a period. Now let's set up our x-axis. We're interested in 1/4 of the way through a period. We're interested in halfway through a period and 3/4 of the way through. So our period is not changing. Our x value is what the cosine function is being applied to, is just 1. So our period is 2 pi. So it's going to make 1 full revolution around the unit circle in 2 pi. So halfway through that revolution is pi, if we're going for 2 pi as 1 full revolution. Then we have pi halves. And finally, we have 3 pi halves. I lost that. So right here is 3 pi halves. So these are the points we're interested in. So we've already accounted for the plus 1. We're good on that end. Now we need to account for the negative. So what a negative does when we take the negative of a function, so like -x² would make it open down. Well, when we talk about it opening down, we're actually reflecting across the x-axis. So trig functions operate in a little different way in that the x-axis isn't what they're based on. They're based on the principal axis. So if we make a negative cosine, it's going to reflect it across the principal axis. So that changes some things for us. Where a cosine function starts at a maximum, it would start at 2, actually, because we've reflected it across this principal axis, it's going to start at a minimum of 0. So there's the first point I'm interested in. Now, as we make our way around 1 full period, 1/4 of the way through, it's at the principal axis. That doesn't change because we reflected across it. Halfway through, it's at a maximum now. 3/4 of the way through, it's back at a principal axis. And finally, 1 full revolution, it is at a minimum again. Cosine functions, actually all these, cosine and sine, both start and end at the same position. So what we have going on is we have this curve. Looks something like this. It's a rough sketch, and there we have it. Now, this just looks like almost a quadratic opening down, but we forget that, or we need to remember, I should say, that there's other values occurring here. It's rotating or making full revolutions over and over and over again. So if we actually type this into Desmos, let's go ahead and do that. Negative cosine x plus 1. Let's just transform this. Negative, there's our reflection, plus 1. What we're looking at is from 0 to 2 pi. So we're just looking at this section or this portion of the function, but we know it actually keeps oscillating over and over and over again. So that wraps it up for week 1. I hope these videos were helpful in helping your understanding further. Again, be patient with this process. We're all still learning along the way, and we'll look for more videos and look for more of me to come in the future. Thanks.